In many applications, we need to perform calculations on entire vectors. Take, for example, plotting an equation. Here, we calculated each value individually, so we only did 5 points, resulting in a rough plot. To make a smoother curve, we'd need to repeat the calculation for many values of x. We can create a large vector of x values using the colon operator. But do we still have to calculate the y values individually? Let's try using the vector x in a calculation the same way we previously used a scalar and see what happens. Uh-oh, what's going on? MATLAB is designed to perform operations on matrices. In fact, MATLAB is short for Matrix Laboratory. The multiplication, power, and division operators are reserved to work with matrices, which is not what we want to do here. We need to square each element of x. No problem. With one small change, we can perform element-wise operations. Take these two vectors as an example. To multiply the corresponding elements of the vectors v1 and v2, we use the element-wise multiplication operator, dot star. Similarly, we can do element-wise division and exponentiation by adding a dot before the division and power operators. There are no special operators for element-wise addition and subtraction because they are the same for scalars, vectors, and matrices. There are a couple of common mistakes to watch out for. It's easy to forget the dot when doing element-wise operations, or to accidentally use vectors of different sizes. When this happens, we get an error message about matrix dimensions? What? Don't worry. If you're not using matrices but get a matrix dimension error while trying to perform an operation on corresponding elements of two vectors, check that you're using the element-wise operators, that your vectors have the same number of elements, and that the vectors are both row or both column vectors. Now back to that function we want to plot. Since x is a vector, we need to use the element-wise power operator to square each element of x. Let's see how this expression is evaluated. First, each element of x is squared. Then, each element of the two vectors are multiplied by the scalar. Finally, when adding or subtracting scalars and vectors, the scalar is automatically expanded to match the size of the vector before performing the addition or subtraction. And there you go. Using element-wise operations, we created a vector of y values calculated for each point in x. Now this plot more accurately represents the function. Try plotting a few equations yourself. Use the colon operator to create a vector of closely spaced x values and element-wise operators to calculate all the y values in a single expression.